Hey guys, welcome back. This is Professor Rodan with College Algebra 1.6, other types of equations. And there's a lot of equations we need to go over. So hang in there and we'll get through this together. Okay? You will need a graphing calculator or a graphing app just to check some of your answers. And we'll talk about that later. So let's get started. Okay, so as we look at number 1, we can see that there's a power of 4. And what this is telling us is that the type of equation we're looking at are basically higher powers of x. And these basically can be reduced to a more familiar equation, which would be the x squared equation. Okay, we spent a whole section on that. Different strategies like solve by factoring, quadratic formula, the sneaky ninja, and all kinds of different things that can appear, and even graphing. So let's go ahead and, our strategy here is to factor out the GCF, okay? And you want to do that first. So we want to see what's the greatest common factor between 4x to the 4th and negative 16x squared. And that's basically going to be 4x squared. Okay. And then what's going to be remaining in the parentheses would be, once you divide out 4x from each term, is x squared minus 4. Now you could factor x squared minus 4 to another two factors there, but it's not necessary to do that unless you want to. But I'm just going to go ahead and use the technique that we talked about, which would be to isolate the x. Okay, so for both of these, we're going to use the zero product property, which allows us to check the x's that will make each of these factors 0. And so on the left, we're going to divide by 4 and get 0 on the right. Still, take the square root of both sides. And of course, that's going to be 0. And over here, like I said, we could factor these, but we're just going to leave it alone and add this 4 to the other side as we isolate. Take the square root of both sides, and that's going to give us plus or minus 2. Okay, so it looks like we have 3 solutions. So let's just check algebra numerically to make sure these are all okay. Just in case you're thinking, how in the world can we get 3 solutions? And I'll show you why in a minute. But let's just go ahead and check it numerically. Let me rewrite that. Okay, so the first one, let's check the 0. That's the easiest one. So you plug in this in. 4 times 0 to the 4th minus 16, 0 squared. And of course, that's 0, all 0. So that one's good. What about x equals negative 2? So this is positive 16, and that's positive 4. So that looks like it's the same thing, right? 4 times 16 minus 16 times 4. So basically that's going to be Doesn't matter what those numbers are, it's going to be 0. It's the same thing. Okay, and then we can do the next one, which is positive 2. Well, if you check the positive 2 and you use these powers, they're even powers, it's going to give you the same result, right? Wait a second, I messed up here. Square. Okay, so this all checks out, and you don't really have to check these unless you just want to make sure you are right, because these are quadratic, and there's nothing prohibiting the domain from excluding any of these solutions. Let's go ahead and take a look at the graph of this. So we want to go ahead and check graphically. Just to show you the two ways you can check all these equations that we're going to be doing today. So you're going to need the Desmos app, or the Desmos.com, or the app, okay, or any other graphing program, either graphing calculator or some other device. Okay, just remember this is just to check your work, to check your homework, but you cannot use this on the test. So what you're going to be looking for, because these equal 0, everything is on the left side, you're going to check the x coordinates, okay? I'm sorry, the x-intercepts. You're looking for the x-intercepts. So once you do this in Desmos, you will see that the graph looks like this, something to this effect. Okay, so there's an intersection here, intercept here, and an intercept here. And if you click on those, you will see that this is a -2 for x, this is 0 for x, and that's a +2 for x, okay? And this basically verifies our solutions. So then our solution set will be, and I like to do this in just the way the graph lists them from left to right. So you look at that picture, -2, 0, and 2. Okay? Okay, the next one. You may be asking yourself, well, what do I do first? Should I move the 45x squared to the left, or should I divide by 4? Divide by 5. And it doesn't really matter which one. I'll just do them both ways so you can see. So if you wanted to go ahead and divide by 5, which is fine, that's going to give you 9x squared, and then you do have to move the 9x squared to the left, and then get a GCF, which is x squared. And then this equals 0, and this one equals 0. Oops. So then x equals 0 here, and x equals ±3. Well, if you did it without dividing by 5, you're going to get the same thing. So if we just move the 45x over, that's fine. GCF this time is a 5x to the 5x squared, leaving you with the same factor inside. Okay, so they both, either way you do, you still get x squared minus 9. And so now we continue this. And you get the same thing, okay? All right, what you do not want to do is dividing both sides by x squared, okay? You should never divide by an x on both sides, because you might eliminate the x equals 0 solution, okay, from your list. You might get the plus or minus 3, but you're going to be leaving out the x equals 0. So I wouldn't do that in either case. Just do either the one on the left or the one on the right here. All right, so why don't you go ahead and try number 3 on your own, and pause the video and see how you did. Okay, so here's a solution for number 3. We just did everything exactly the same way. Move the 27x to the left, take out the GCF, separate each factor. I think I skipped this step here. But that's fine. It's fine to skip a few steps here as you're doing these, okay? And then the final solution is -3, 0, and 3. All right, so the next set of problems are from radical equations, and then we're going to take a look at these. And note that when solving radical equations, always check proposed solutions in the original equation. So this is where we actually have to check our solutions, because we may end up throwing out one or both of them, okay? So this is something that I warned you about in providing proposed solutions, and then getting those proposed solutions into the solution set. Now we will have to take that seriously. So here, our strategy is that we want to isolate the radical first, and then we want to square both sides. So isolate the radical first, if necessary, which most of the time it is. Then square both sides, or raise it to the power of 2. Okay? So this one right here is already isolated. So no need to isolate anything. We just go ahead and square both sides. And the reason why we do that is it gets rid of the square root on the left side. So negative x squared is positive x squared. Then we want to go ahead and we want to get these quadratics in the form, in standard form, okay? So if you remember, standard form is ax squared plus bx plus c equals 0. So we got to get 0 on one side. Doesn't matter which side. So since the x squared is already on the right, I'm going to go ahead and move the 6 to the right and this term. So I'm going to just move them at the same time, which is fine. And it looks like I'm making some stray marks down here. Let me fix that. Okay. So what that's going to do is make this as so. Okay. So we can go ahead and rewrite this. Okay, you always want to try to factor, because that's probably the fastest way. And so we take a look at, see, -6, so we need a positive and a negative number. So that's going to be, and the result is in the middle is a positive. So remember, we can do 1 times 6 or 2 times 3. So we're going to choose, since we're subtracting here, this is we're going to be subtracting our factors because we know one of them must be negative. So that's going to be -1, +6. That equals my +5. So we just put our 6 here, -1 here. These are this zero product property. And now we have two proposed solutions. Okay, so we're going to go ahead and check each one of these. So let's try the x equals -6. On the original. So okay, so the right side is the easiest. That's going to be +6. The left side is going to be 6 plus 30, which is 36. And that checks out. Okay, so he's definitely a solution. So let's check out the other one. So the right side is -1, and the left side is +1, and that does not equal. So we need to throw out x equals 1 as a solution. So our final answer then is going to be just -6. Okay, and you can check that graphically to make sure that it is correct. Actually, let's go ahead and do that. So graphically, you can use either the intercept method or the intersection of graphs method. I think we should just probably do this one, which is the moving everything to one side, and you're going to look for x-intercepts. So if you put, so what that means is you put these two into the left side and into your equation, and you're graphing utility here. Move this to the right, and so you're going to graph this right here. So let's take a look at that. All right, so if you put this into a graphing utility, just a second here. Let's see. Okay, as you can see, I typed in the full equation with the right side equals 0, so the x is on the left side now, positive. And you can see the intersection is at -6. Okay, and there is no right intersection, it kind of just stops. So this is why we have to throw out the 1, okay? It just does not intersect the x-axis on the right side. All right, so let's take a look at the next one. And This time you do have to isolate the x. And all that takes is one simple step, and that's just get this 2 to the right side. And now you have this quadratic here. So now you can square both sides. So I'm going to stop here and see how you do with this. So pause the video and I'll see you in a few minutes. All right, so here's the solution to number 5, all worked out. Now, the squaring of x minus 2, I use a little shortcut that you can use, or you can just do it the long way. It doesn't really matter. But basically, I knew that I would square the first term to get x squared. Square the second term would be plus 4. And then right here, you multiply those two together and double it, and you get negative 4. Okay, so basically it comes from this pattern. The O and the I of FOIL is always the same. So it's just going to be negative 2x plus negative 2x is negative 4x. So I just kind of, instead of writing all that, just kind of did this part. Okay, but you're welcome to provide more steps in between right here. All right, moving everything to the right, getting our new quadratic right here. Then squaring it, factoring it. Negative 1 times negative 5 is positive 5. Negative 5 plus negative 1 is negative 6. So then x is 1 there, and x is 5 here. We checked 1. 1 did not check out. Okay, it was not going to work. And then check the 5 right there, and it did check out. So 5 is our solution. All right, let's go to the next one. So number 6, number 6 is kind of long. It's actually pretty long. So you're gonna have to use right small and try to use both columns. Everything that you have down there available to you. Okay. So first of all, our strategy here is going to isolate one of the radicals. So you have 2. Okay, and one of those square roots. So I would like to go ahead and move the one on the right, the second one to the right side. So our new equation now is this on the left and this on the right. So we need to go ahead and square both sides, and you can see it's going to create a nice little problem on the right side. Okay. So you could do the same pattern I did up there, if you know how to do that. I'm not. I'm going to go ahead and separate this all out. So x plus 4, square root of x plus 4, square root of x plus 4 plus, so just repeat those and then do FOIL. So the first term, let's just say x plus 4 squared, okay, because there's 2 of them. And the next one, actually the next 2 is just going to be the exact same thing, okay? So you have 2 of these guys. O and I of FOIL are identical. That's why the pattern says to go ahead and double it, but we'll just do that later. And then the last one is 1 times 1, which is 1. So what we're going to do is put those two together to make 2 of those. And the power of 2 and the square root, they're opposites, they're inverses, so they actually cancel the signs out, not the term. So the sign is canceled out. That's great. Leaves us x plus 4 by itself. These two are 2x plus 4, radical x plus 4s. And I'm getting the 2 from the 1 plus the 1 right there. The coefficient of those guys. And then plus 1 just comes straight down. So let's go ahead and simplify these two. So that's just going to be 5. Then we want to go ahead and isolate the radical again. Okay, so this problem involves isolating twice. Okay, so if we need to isolate that radical, there's a couple things we need to do. Let's move these two guys to the other side. So that's going to be 2x, minus 4. And then we need to divide by this 2. So that cancels that out. So now my radical is isolated. But on the left, go ahead and divide by 2 in both terms. So that's going to be x minus 2 there. And now we square both sides like we did before. So remember, the whole purpose of squaring both sides is to get rid of the radical on the right, but it creates a little monster on the left, which is okay. We can deal with that. Let's go ahead and get in standard form. So everything on the right moves to the left, making it 0 on the right. And now we have to calculate our like terms. So that's negative 5x, and that's basically 0, right there. So the strategy for having the c term missing is GCF. So both terms have an x equals 0, and x equals 5. Okay. And when you go to check this, let me just say that the answer is 5 to save a little bit of time. And when you check the 0, this really doesn't make too much sense, so that's not going to work. Okay. So you need to go ahead and throw this out. All right. All right. That probably took a whole page of work. All right, let's go to the next one. All right, let's go to number 7 and 8. And actually 9 as well. Well, let me go ahead and get you guys to do this on your own and check back to see the solution, okay? Now, I do want to give you a few hints, and that is, so hints. For 7 and 8. So the quadratic, let me just say it this way. Use the quadratic formula okay, in the third step. So when you go to solve the quadratic function that's created, then it's not going to be factorable. Okay, so you want to go ahead and just use the quadratic formula. So that's my hint for 7 and 8. See you in a few minutes. All right, we're back. Hopefully you pause the video and work these out on your own using my hints for number 7 and 8. And now you also continue to number 9. So again, the answer to number 7, we have to use the quadratic formula. And this is the way I do quadratic formula. I do my scratch work on the side for the radical, or the radical over here, and insert that in there so there's not so many steps going around, and end up getting 6 plus or minus 2 times radical 6, and I have to throw out the 6 minus the 2, radical 6. Okay, and I highly recommend you check that in a graphing calculator to throw out the left one. Yeah, so it's going to be complicated to insert that into the equation. I will definitely make sure that's not on the test as something you have to verify without a graphing calculator. But for the homework, I guess it shouldn't be too bad, since you have a graphing calculator to help you check these solutions. Number 8, same thing, not factorable, use quadratic formula. And again, I have to throw out the 2 minus radical 6, okay, as it was not a solution. And you can check the graph with that. Feel free to pause this if you need to look at it more. And number 9 is no solution. Okay, no solution, because after we did all this work, we ended up getting this -1 right here. And a radical really can't equal -1, or at least, yeah, this one does not equal -1, okay? Radicals, just like what we're about to do, is absolute value. Absolute value cannot equal negative, and neither can radicals, okay? It's just not in the domain, and I can show you the visual of that, but if you go up here and type this in, okay, you will see that there's no intersection. Okay. All right, we're gonna go ahead and move on. Okay, so we're gonna go ahead and go to number 10, and these are equations with fraction powers. So I do want to quickly review some things before we do this, so you have a better understanding of why we're going to use the strategy that we're going to use. So first of all, recall if you have something like this, we would take the square roots of both sides, and you know that we would get x equals plus or minus 2, right? So we've been doing this a lot. But the question is why? So you say, hey, it's a square, so we do the square root. Those are inverses. You're right. But actually, we've been actually doing something else as well, and you can check you can check the calculator for this. So we've been also raising this. So another way to do the square root is to raise it to the 1/2 power. Okay. So if you put in your calculator this right here, okay, you may have to do type in 4 caret, and you may have to type in a fraction button, whatever that looks like for you. Actually put parentheses, fraction, and then do your 1/2, close the parentheses, and then click equals. Anyways, figure that out on your calculator, however it's done, and you can verify that 4 raised to the 1/2 power is also 2. Now, it's not going to give you the plus or minus, but we know that's 2. Okay? So as you can see, what happened there was 2 times 1/2, that equals 1. All right? So the general form of this is a to the m over n, so a fraction power, is actually like the square root. So the 1/2 is actually, 1/2 power is a square root. How? Okay, so it's root n, or the numerator, I'm sorry, denominator. Okay, and the power of the numerator. So this is the denominator, and this is the numerator. Okay, and then of course you have the base. Now actually, what's even better than that we need to use is we can pull out that power and leave it on the outside. Okay, that's going to be helpful, as you're going to see a little bit in just a minute as we calculate these in our heads. Okay, so this is the form we're going to use. So our strategy then is we want to go ahead and cancel out those fraction powers. And the way we do that is by using reciprocals. Oops. So we're going to raise both sides to the reciprocal power. So we're going to take this x to the 3 over 2, and we're going to flip it, that's the reciprocal, and raise it to the 2 over 3. Both sides. Whatever you do to one side, you got to do to the other side to keep it balanced. And so what happens is you got 3 over 2 times 2 over 3. And if you multiply reciprocals, okay, so for in this case, you have 3 over 2 times 2 over 3. Well, that's actually 6 over 6, which is just 1. Or you can just say, hey, 2's cancel out, 3's cancel out, which is equal to 1. Okay? So that's why we do this, because we're trying to get x by itself. But in the process of doing that, we get cube root of 27 squared. So again, uh-oh. There we go. So the left side is great. We get x. So now we have the cube root of 27 squared. Well, remember, what we're going to use over here on, whoops. So if you look to the right of the video, you can see that we're going to pull out the power, because 27 squared is a huge number. And we can actually do this if we take the root first and then square. Okay, so what's the cube root of 27? Cube root of 27 is 3. And then 3 squared is 9. Okay? And you may be saying, well, I thought when we take the square root, we have a plus or minus answer. That is true, because that is an even root. Okay? But for odd roots, this is an odd root, cube root. So odd roots are only positive. So only positive, not positive and negative. Only positive if inside is positive. And same thing with negative. Only negative if the inside is negative. Okay? So the roots, if it's odd, like 3, 5, 7, you're only going to get one answer this time. If you have a even power root, like square root, which is 2, fourth root, sixth root, so on and so forth, you're going to get 2 answers, the positive and negative versions. Okay? So let's take a look at another example, a couple more examples here. So we're going to go ahead and raise this. We're going to flip this. So that cancels out. We get x. And this is basically the root 2. That's the denominator. That's square root. 16. And we're going to put this all on the outside for the 3. Or the 3 on the outside. And everything else on the inside. So that helps us do this in our heads, because the square root of 16 is 4. I'd rather do that than do the cube root of 16, which is a gigantic number. So the cube root, the square root of 16 is 4. And I'm sorry, I messed up. So since this is an even root, like I said before, you're going to have both positive and negative answers. Okay? So the even root I'm talking about is this 2. So the square root of 16 is plus or minus 4, and we cube both of those, and we're going to get 4 cubed and negative 4 cubed. And 4 cubed is 64 positive, and negative 4 cubed is negative 64. Okay? Those are our proposed solutions. You don't have to necessarily check these. And you're done. Okay, let's take a look at the next 3. So same process. Whoops, we're going to raise both sides to the reciprocal power, and that cancels out our power, so we just get x to the first power. In the process of doing that, we get this square root of 32, all that to the 5th power, and the square root of 32 is just it's not going to work. So I've been trying to find an example in my math app, couldn't find it, but I did see in the book that they left the answer as a fraction power. Okay? So they just left it like that. Now, if we were to try to simplify this, let me do this in a different color. So if we need to do this, then we would have to do something like so this is all in the fifth power. So so it kind of looks like that. It doesn't really help that much. 4 to the fifth power, I guess it's not that bad. Well, actually, it's kind of a big number. It's 1,024. Yeah, so this is not a very nice example. Maybe there's a typo, and the 2/5 should be 5/2 to begin with. That would actually make it a lot better. But the way it is, like I said, I couldn't see an example in. I'm sorry, there should be 2 of those, right? It's a square root. So, yeah, I didn't really see any examples, but just in case there are, then it will look something like this, okay? If you can find any, I didn't. Hopefully you don't, but if you do, let me know. But it should look something weird like that, okay? Okay, so let's go ahead and take a look at the next 2, numbers 13 and 14. I'm gonna do 13, and then you're gonna try 14 on your own. So again, we're gonna raise this to the reciprocal power. So the 2/3 becomes 3/2. So this cancels out, gives us a nice x plus 4. And then this is going to be square root of 9 raised to the 3rd power, which is 3. Actually, plus or minus 3. Sorry. So this is plus or minus 27. So now, subtract 4 from both sides. So our proposed solution is -4 plus or minus 27. And if you do each of those, you're going to get, 27 minus 4, 20, -4 minus 27 is -31. And 27 minus 4 is 23. Okay? So go ahead and try number 14. Pause the video and see you in a few minutes. All right, so we're back. Here's the solution, -13 and 3. And this is how I got it. So just follow the same procedures. The first step is pretty much the new one. Do the calculation where there's an even power. So we have we have the both positive and negative, even root. So we have both positive and negative answers to the 4. We're going to cube each of those, which get positive -8. and then move the 5 over, and we get our two solutions here. Okay? All right, let me know if you have any questions through email or in class. And we're going to go ahead and move on to the next type of equation, which is absolute value. Okay, so let's take a look at absolute value, number 15. Just want to point out a few things first, like recall that the absolute value so like for example, absolute value of 4 is 4 and the absolute value of negative 4 is 4. Now why is that? Because it's the absolute value is the distance from 0. Okay, so the distance from 0 of, oh, that's not good. The distance of 0 the distance from 0 of positive 4 is 4. And the distance over here, doesn't matter if it's negative, the distance is still 4. Okay, distance is always positive. So in either case, the distance from 0 is 4. This is why you have this. So now, if we say, okay, well, let's take a look at it in a different way. The absolute value of x that equals 4, well, there's two x's that would make that 4. Okay, so we can see on the left, okay, there's two x's. So basically, when you get an absolute value equation, you're going to get two equations. Okay, one that's positive and one that's negative. Okay? So our strategy here then for absolute value equations is to solve two equations. Okay? These two equations is basically one that's positive and one that's negative. Okay? So we're going to just say, okay, x plus 5 equals 2. That's the positive version. And then the other one is x plus 5 equals negative 2. That's the negative version. Okay? And we solve each of these. We get our two solutions. Let's go ahead and check that to see. So this one checks. And if we check the other one, same thing. Okay? So our solution set would be -7 and -3. Okay, now, why is that? Again, here's the visual. So that absolute value equation is like around here somewhere. It's a v function. Okay. And then where it equals 2, it's basically up here. And so you have two answers, two intersections. Okay. You can verify this on the graph. So this right here is -7, and this right here is -3. Those two locations. So this is why we're getting two solutions again. And we're going to go ahead and try number 16 on your own. Pause the video and see you in a few minutes. Okay, so we're back and the solution is -3, 5. So it's pretty straightforward. You can check those if you want, graphically or numerically. And let's continue here. So we have a weird looking one, number 17. So the strategy here is very similar to what we did in the radicals. And that is to first isolate, but this time we're isolating the absolute value. Okay, and then second, actually let me do it this way. Solve two equations like we talked about, one positive and one negative. Okay, so it's going to take us a couple steps to get this thing isolated. First, we're going to move the 1 over. So we get 12, and we divide both sides by 6, and finally get 2. So we're going to solve two equations from this. 3x equals 2 and 3x equals negative 2. So x is going to be 2/3, and over here x is going to be negative 2/3. Okay? And you can check those out. Pause the video if you need to. And number 18, go ahead and try this one, okay? Okay, so there's number 18, negative 3 and 11. Added the 2 over. Subtracted the 2 over to get 7, and solve two equations. Okay, so that's it for this page. Let's go to 19 through 22. So let me do one more, and then you can do the rest on your own. So this one's a little weird, even though it doesn't look like it. See, you just do the normal thing here. Okay. But this time you get a negative result. Okay. So this right here, guys, this is not possible with absolute value. So we get no solutions. Okay. No solutions would look like this. Empty set or the null set. Sorry about that. Okay. So what you need to remember is that absolute value both results are positive when we insert numbers in absolute values. They make the results positive. So you can never ever get a negative result and now let me show you the picture of this, okay? So if you graph those two, if you graph this, so basically you're looking at something over here on the left side. It's a V, and then you're asking, now if I ask you for a positive number, it's up in the top half, but a negative number is actually in the bottom half. So let's say negative 7 is right here. So the question is, when do these two equations equal each other, the absolute value and the negative 7? Never. As you can see from the picture, they do not cross or intersect. So this is why you got to check for if your value is negative on the right side, because if it is, then there is no solutions, okay? So what I want you to do at this time is go ahead and try 20, 21, and 22 on your own and see how you do. And I'll be with you in a few minutes. As you finish those, go ahead and pause the video. Okay, we're back. And these are the solutions for the last three from this section. So the number 20 is negative 5 and 1. Number 21 is 0 and 10. And 22 is no solution or empty set, because once we subtracted the 12, we get a negative 3. And this is not possible. So there you have it, guys. We went through various different types of equations, and so hopefully you have a good set of notes to help you with your online work. And please email me if you have any questions, and I'll see you in class. All right, bye-bye.